Welcome back to RS Academy. This is Ravi Shankar. We are discussing fourth chapter, that is carbon and its compounds. In that, so many videos I have done. So please go to the previous videos. In this session, let us have a talk regarding to organic compounds. Good evening, my dear. Organic compounds. Organic compounds. Organic compounds. What is meant by organic compounds? So according to so many chemists, organic compounds are nothing but are the compounds obtained from the living organisms. Living organisms. Obtained from the living organisms. So according to J.J. Berzelius, organic compounds are obtained from the living organisms by vital force. Vital force. Vital force. According to J.J. Berzelius, Sweden chemist J.J. Berzelius. Organic compounds means those are compounds are obtained from the living organisms by vital force, according to J.J. Berzelius. J.J. Berzelius suggested that or proposed that organic compounds are obtained from the living organisms by under the influence of vital force. So what is vital force? He said that vital force is nothing but the mysterious force which is necessary for the obtaining of organic compounds in the living organism. So based on this point, he was proposed that vital force theory. Vital force theory. So vital force theory was given by J.J. Berzelius. What is vital force theory? According to vital force theory, organic compounds are obtained from the living organism, are obtained inside of the living organism by mysterious force. Next one. So one more point he was said that is organic compounds cannot be prepared in the laboratory because of we are unable to create the favorable condition which is necessary for obtaining of organic compounds. That is vital force. We can't create the vital force in the laboratory, so that's why it's a very difficult to prepare the organic compounds in the laboratory. But Friedrich Hohler prepared organic compounds in 1828. So, listen carefully. Organic compound means those compounds are obtained from the living organism, and these organic compounds are obtained from living organism by vital force. So, according to J.J. Berzelius, the mysterious force is necessary to obtain chemical organic compounds in the living organism. So, based on this, he was proposed that vital force theory. Right. And not only that, he has given one challenge to the remaining scientists or chemists. That is, so we can't prepare organic compounds in the laboratory because of we can't create the favorable condition which is necessary for the obtaining of organic compounds. But in 1828, Friedrich Hohler disproved vital force theory. He was prepared one organic compound in the laboratory in 1828. So that's why Friedrich Hohler is considered as father of organic chemistry. Father of organic chemistry. Father of organic chemistry. Father of organic chemistry. He was prepared organic compound by heating of ammonium sulfate with potassium cyanate. Potassium cyanate. He got ammonium cyanate along with potassium sulfate. Potassium sulfate. From ammonium cyanate, he got urea. From ammonium, the rearrangement of ammonium cyanate on heating, he got urea. So urea is organic compound. Urea is organic compound. Listen to me. According to J.J. Berzelius, organic compounds can't be obtained or can't be prepared in the laboratory because of the required vital force to prepare organic compounds. So we can't create the vital force in the laboratory. So that's why it's a very difficult to get the preparation of organic compounds in the laboratory. So this theory is called vital force theory. Vital force theory was disproved by Friedrich Kohler in 1828 by preparing urea itself is organic compound from inorganic source. So that's why Friedrich Kohler is considered as father of organic chemistry. So this is also urea is the organic compound found in the urine of mammals, right? So by preparing urea, he disproved the vital force theory. So based on these lines, you will get very important bits. One is name the scientist who proposed vital force theory. Second one is name the scientist who disproved the vital force theory. Next one, name the organic compound first which is prepared in the laboratory. From which source? Inorganic source. Make a note. So in 1828, Friedrich Kohler prepared urea in the laboratory. This was urea. Next one in 1820, after Friedrich Kohler, Henry was prepared ethyl alcohol, ethanol or ethyl alcohol, ethanol in the laboratory. So 1845, Kolb prepared acetic acid or ethanoic acid or acetic acid. Next one, in 1856, Berthelot prepared methane. So nowadays, nearly 90% of organic compounds are prepared in the laboratory. So very important. So these are the first organic compounds prepared in the laboratory by various scientists. Okay. Next one, make a note. So next one, what is the main constituents of organic compounds? So organic compounds are mainly made up of or consist of carbon, hydrogen along with spoon X. Carbon, hydrogen along with spoon X. That means the carbon, hydrogen, sulfur, phosphorus, oxygen, nitrogen. X means halogen. Halogens are nothing but fluorine, chlorine, bromine and iodine. So these are the main constituents of organic compounds. Listen carefully. Organic compounds means the compounds are obtained from the living organisms. Not only that, they can prepare in the laboratory as well. Next one, organic compounds mainly contains carbon and hydrogen along with sulfur, phosphorus, oxygen, nitrogen and halogens. So these elements are called heteroatoms. These are called heteroatoms. So these are the few words regarding to what is meant by organic compounds. Kind of hybridization in organic compounds. Generally, carbon exhibits three types of hybridization in organic compounds. One is sp3 hybridization, second one sp2 hybridization, third one will be sp hybridization. sp3, sp2 and sp hybridization. sp3, sp2 and sp hybridization. So let us have a talk one by one. So put it in sp3 hybridization. sp3 hybridization. sp3 hybridization. So what is meant by sp3 hybridization? In sp3 hybridization, one s orbital and three p orbitals are mixed together and undergoes hybridization, produce four equal energy sp3 hybridized orbitals. Four equal energical sp3 hybridized orbitals. Listen to me. In sp3 hybridization, one s orbital and three p orbitals mix together and gives four sp3 hybrid orbitals. Four sp3 hybrid orbitals. In case of carbon, let us have a talk. Carbon electronic configuration 1s2, 2s2, 2p2. In excited state, electronic configuration will be 2s1 and like this one. We need to transfer one electron from 2s to 2p in order to get four unpaired electrons. So is s and 3p orbitals. So one s and 3p orbitals mixed together gives four sp3 hybrid orbitals. Four sp3 hybrid orbitals like this. Right? So you will get tetrahedral structure. Tetrahedral structure. So this one is a sp3 hybridized shape and structure of the sp3 hybridized carbon atom. In case of sp3 hybridization, one s orbital and three p orbitals mixed together gives equal energetical hybrid orbitals, that is four sp3 hybrid orbitals. These four sp3 hybrid orbitals arranged in tetrahedral shape. The bond angle will be 109.28 or 109.5 degrees. So this is a bond angle of sp3 hybridized carbon. Make a note. Now let us have a talk in detail regarding to sp3 hybridized carbon with the help of one example. Get ready, my dears. Methane. In methane, one carbon atom gets attached with four hydrogen atoms. I said central atom undergoes hybridization. In carbon, one s orbital and three p orbitals undergoes hybridization and produce four sp3 hybrid orbitals like this. Four sp3 hybrid orbitals. Four sp3 hybrid orbitals. sp3, 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 sp3. These four sp3 hybrid orbitals overlap with s orbitals of hydrogen. So each hydrogen electronic configuration 1s1. So electron is in the s orbital. The shape of s orbital is spherical shape. So these are overlap like this. This is the s orbital of hydrogen, 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 hydrogen. So the overlapping results formation of sigma bond. Then the structure shape tetrahedral shape. Tetrahedral in shape. Make a note. Hybridization of carbon sp3 hybridization of carbon in ethane. Ethane C2H6. This is a detailed structure. In this, each carbon undergoes sp3 hybridization. Let us take this one is one of the sp3 hybridized carbon, and this one is another sp3 hybridized carbon. sp3 hybridized carbon. You will get like this. Right. So these are two sp3 hybridized carbon. So gives four equal energetical hybridized orbitals, sp3 hybridized orbitals, and this carbon also undergoes hybridization and produce four equal energetical sp3 hybridized orbitals. So these two are overlap and form sigma bond, and remaining these are overlap with s orbitals of hydrogen. This one with hydrogen, hydrogen, hydrogen. This one with hydrogen, hydrogen, hydrogen. In case of ethane, carbon undergoes to sp3 hybridization. That means, based on this, we came to know that if the carbon gives only four single bonds with neighboring atoms of elements, then it must be considered as sp3 hybridization. sp3 hybridization. If the carbon gives only single bonds with neighboring, that carbon must be considered as sp3 hybridized carbon. Is it clear? Make a note. Next one, sp2 hybridization. sp2 hybridization. If the carbon gives at least one double bond with neighboring, that carbon is considered as sp3 hybridized carbon. So let us take very simple example, that is ethene C2H4. Ethane. In this one, carbon giving 3 sigma bonds with neighboring atoms. So this carbon gives 2 sigma bonds with hydrogens. This carbon gives 2 sigma bonds with other hydrogen atoms, and these two are undergoes and give each other 1 sigma bond. So to form sigma bonds, we require hybrid orbitals. That means in this case, carbon should give only 3 bonds with neighboring, 3 sigma bonds with neighboring. Right? Carbon 1s2, 2s2, 2p2. On excited state, one electron of S must be transferred to P in order to get 4 unpaired electrons. 4 unpaired electrons. In this one, we require only 3 orbitals, so that's why 1 s orbital, 2 p orbitals undergoes hybridization. 1 s orbital and 3 p orbitals. 1 s orbital of each carbon, 1 s orbital and 2 p orbitals of each carbon undergoes sp2 hybridization and give equal energetical sp2 hybridized orbitals. Okay, right? This one. Then what about other carbon atom? This is another carbon atom. These are sp2 hybridized orbitals. 3 sp2 hybridized. sp2, 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 sp2. But here one unhybrid orbital is remained on each carbon. So that unhybrid orbitals represented with dotted lines. This is an unhybridized orbital. Unhybridized orbital. That means pure atomic orbital. Unhybridized orbital. So these unhybridized orbitals are overlap each other, form pi bond. So pi bond is found by unhybridized orbitals. Sigma bonds are found by hybridized orbitals. Now these two are overlap with hydrogen, s orbital of hydrogen, and these two are also overlap with s orbitals of hydrogen. A structure like this. Let me draw here. C double bond H H H H H. Right. So total 3 sigma bonds, 1 pi bond given by one carbon atom, and this one is formed by 3 sigma bonds and 1 pi bond again. Okay, right? So in this one, each carbon undergoes sp2 hybridization. Each carbon undergoes sp2 hybridization. The shape of the sp2 hybridized carbon structure, that is trigonal planar structure. Trigonal planar. Okay, make a note. sp hybridization. In this one, only s orbital and p orbital of carbon atoms undergoes hybridization and produce equal identical to sp2 hybrid orbitals. So carbon 1s2, 2s2, 2p2. On excitation state, we need to transfer one electron from s to p as shown in the figure. Are you following, my dears? Right? This one, sp2 hybridization. Example, ethine. Ethine. This is the structure of ethine. Ethine undergoes, in case of ethine, each carbon undergoes sp hybridization. That means we require one sp orbital and one p orbital, and remaining two p orbitals are unhybridized. Listen carefully. So these two are hybridized, sp hybridized orbitals of one carbon atom, and these two are sp hybridized orbitals of another carbon atom. Okay, and two orbitals are remain unhybridized. Let me draw with the help of dotted lines like this. One more. Right. These hybrid orbitals overlap with hydrogen and form sigma bond, and this one also overlap with hydrogen, form sigma bond, and these two are undergoes overlapping and form sigma bond. So these are unhybrid p orbitals are overlap and produce pi bond. Right. In case of ethine, 3 sigma bonds are present and 2 pi bonds are present. The pi bonds are formed by the sidewise overlap of unhybridized orbitals. Sigma bond is formed by head-on head overlap or axial overlap of hybridized orbitals. So that's why sigma bond is very strong when compared with pi bond. So let me conclude. So if the carbon gives only sigma bonds with neighboring, this carbon is considered as sp3 hybridized carbon. If the carbon gives at least one pi bond, that means one double bond with neighboring atoms, this carbon is considered as sp2 carbon. And if the carbon gives at least one triple bond with neighboring, then this carbon must be considered as sp3 hybridized carbon. So this is the hybridization of carbon in organic compounds. In case of sp3 hybridization, the structure of organic compound will be tetrahedral structure. In case of sp2, trigonal planar. In case of sp, linear. Please make a note. Next one, structural representation of organic compounds. Very important. Structural representation of organic compounds. Structural representation of organic compounds are in three types: the structural formulae, condensed formulae, and bond line formulae. One more is that is 3D structural representation. After completion of this, let us have a talk about that. No need to worry about it. So mainly three: structural formulae, condensed formulae, and bond line formulae. So what is the structural formulae? In case of structural formulae, all atoms are appears. Atoms are appears. Next one, a representation also present. Sorry, arrangement. Arrangement of atoms also shown. Third one, bonds also present. Bonds. These three parameters are shown in case of structural formulae. One is atoms of different elements are must be shown, and arrangement, how they are arranged in the given molecule. Next one, what kind of bonds are present in the atoms of different elements in the given molecule. So these three are shown in the given structure. This kind of structure is called structural formula. Structural formula. Example: acetic acid. This is the structural formula of acetic acid. The formula will be CH3COOH. So here atoms of different elements are shown as we are able to see carbon, hydrogen, and oxygen in this structure. Am I right? Next, arrangement, how they are arranged. How many hydrogen atoms are in first carbon? How many atoms? What kind of atoms are attached to the second carbon as well? So arrangement also we are able to see. Arrangement. Next one, bonds also we are able to see. That means what kind of bonds are present or how many bonds are there in the structural formula. So 1, 2, 3, 4, 5, 6, 7, 8. 8 covalent bonds are present. Among 8 covalent bonds, 1 pi bond and 7 sigma bonds are present. Okay. So in case of structural formula, we are able to see atoms, arrangements of atoms and bonds present between them. Next, then what about condensed formula? In case of condensed formula, bonds are disappears. Very important. Bonds are disappears. So there is no visibility of bonds. Bonds are disappears. Right. In case of condensed formula, atoms are present. Atoms. Arrangement also present. But bonds are disappears. Bonds are disappears. So let us write this structure without bonds. Listen to me. CH3 COOH. So this is called condensed formula. Condensed formula. This one is structural formula. This one is condensed formula. Then what about bond line structure? Bond line. In case of bond lines, atoms or appears only heteroatoms. Heteroatoms. Heteroatoms means other than carbon and hydrogen. Next one. So there is no availability or appearance of the bonds. Next, the bonds between carbon and carbon is represented in zigzag form. In zigzag form. So atoms are appears only heteroatoms, not carbon and hydrogen. Second one is the bonds between carbon carbon is represented in zigzag form. So let us convert this into bond length. So bonds also present. Bonds are appears. Bonds are appears. Right. So this one is a bond line structure. Bond line structure. Is it clear to you? Listen carefully. So organic compounds are represented in different structural formulae. One is structural formula, condensed formula, bond line formula. In case of structural formula, atoms of different elements are appear. At the same time, representation also shown. Bonds also appears. This one is a example of structural formula. Condensed formula. In case of condensed formula, atoms of different elements are appears. Arrangement also present, but bonds will be disappeared. So without bonds, you can write this structure. Next one. In case of bond line formula, only heteroatoms are appear, and the bonds between carbon carbon is represented in the form of zigzag. So this one is a bond line of acetic acid. Please make a note of it. So now let us take one more example. With the help of, let us understand how to draw these three structures. Get ready. So let us take ethyl alcohol, or let us take one bond line structure. This one is. This is a ethyl alcohol. Bond line. What is the detailed structure for this one? Structural formula. Here two carbons are present. Carbon, carbon, CH3, CH3, CH2, OH. This one is structural formula. Then condensed formula, CH3, CH2, OH. In case of class 10 CBSE, you will get only these two structures. These structures you will get in case of plus 1 and plus 2. But so let us have a basic idea regarding to bond line structure, structural formulae and condenser structure. So now let us take one more example. Make a note. This name is butane. After completion of this concept, let us have a talk naming of organic compounds. In the topic you will get how to draw the butane structure, how to name the given structure, this all, no need to worry. So example butane, this is a butane. This is a bond line structure. So there is no other kind of heteroatoms, only carbon and hydrogen present, right? And the bonds between carbon carbon represented in zigzag form, right? Carbon is carbon, carbon, carbon. 4 carbon atoms are there. Let us draw like this. 4 carbon atoms. Carbon tetravalent in nature. Each carbon should give 4 bonds with neighboring. In case of this carbon, it has given one bond with this carbon atom. Remaining must be filled with hydrogens. Then what about this carbon atom? It has given 2 bonds with neighboring carbon atom. Remaining 2 with hydrogen. And this one also same. And this one also, it should give 3 bonds with neighboring. This is a structural formula. This is a bond line formula, bond line structure. Then condensed structure, CH3, CH2, CH2, CH3. Also written like this, CH3, CH2, taken twice CH3. Is it clear to you, my dears? Make a note. Next one. Let us take acetone. Acetone also called propanone. Acetone also called propanone. The bond line structure will be, this is a bond line structure of acetone. Let us write detailed structure. Carbon, carbon, carbon. 3 carbon atoms are present. C double bond O. So remaining carbon valency must be filled with hydrogen. Hydrogen, hydrogen, hydrogen. Hydrogen, hydrogen, hydrogen. This is a structural formula. Condensed formula will be CH3, CO, CH3. This is a acetone. Make a note. Next one, butanoic acid. Are you following, my dears? Please learn these structural representation are very important in case of class 10 and plus 1 plus 2 as well. Please make a note each of every point what I am writing on the board. Next one, let us take butanoic acid. Butanoic acid. Butanoic acid. Bond length structure 1, 2, 3, 4. Butanoic acid. Detailed structure, structural formula 4, 1, 2, 3, 4 carbon atoms. 1, 2, 3, 4 carbon atoms. Double bond O, O1 H. So this 3 carbon atoms filled with, attached with the remaining 3 hydrogen atoms. This with 2 hydrogen atoms, and this also with 2 hydrogen atoms. This is a structural formula. Next one, CH3, CH2, CH2, COOH. This is a condensed formula. Make a note. So try yourself. Draw the, I'm going to give bond line structures. Try yourself. Write the condensed structure and complete structures yourself. Try them. Right. Right. I have given bond line structures of organic compounds. So convert them into condensed structure and complete structures. So comment if you have any doubt, comment in comment box. Thank you, my dears. Have a nice day. Take care.